So after we did lesson 10.1, it was about complex numbers in polar form. Today we'll be doing lesson 10.2 is about the operations with complex number in polar form. And sometimes it's much more easier to multiply and divide and to do some operation of the complex numbers in polar form. It's much more easier than in the standard form, or we say Cartesian form. Now let's see if there is any relation between two complex number when I add. Can I find any relation between the angles? So I will have those two complex numbers. I will erase the figure and draw it again so it will be more clear. If I have two complex number, z1 is equal 4 plus 2i and z2 is equal minus 2 minus 1 plus 3i. I will not draw it to scale. I'll just draw it in a way just to put it in the right quadrant. So this one gonna be here in the first quadrant. So if I say it's approximately here, this is z1 and z2 is in quadrant 2. This is z2. Let's say it's here. So if I'm adding those two complex number, so I need to add the real parts together and the imaginary parts. So I will have a new complex number z3, and z3 gonna be somewhere here. So it's gonna be somewhere here. And if you look at those complex numbers, if you find the modulo of z1, z2, and z3, you can see that I cannot find any relation between those two. Or what can I say that z1 plus z2 gives me the diagonal if I want to take it as a vector. So, and for the angle, if I want to compare the angles, this is theta 1 for z1, this is theta 2, and this is theta 3. Can I find any relation between those three angles? I cannot find any relation between those three angles. So I can say that for adding complex numbers, I can't find any relation in polar form for the addition. All what we need to do is just to add the real part, the imaginary part, and that's it. Now let's move to multiplying by a scalar. Can we find any relation by multiplying a complex number by a scalar? Scalar, it means a number. Let's see. If I have z1 is 4 plus 2i, so I will take again z1 4 plus 2i, and it will be in quadrant 1, so it's here, approximately it's here if I will approximately draw. So this is z1. Let's say this is z1 here. And the modulo of this complex number is radical 16 plus 4, so it's radical 20. It's 2 radical 5. And if I want to find the angle, you know that from the preceding chapters, since I'm in quadrant 1, so tangent theta will be y over x, so it's approximately 26.5. I don't care really about the exact angle here, but I just need to just see if there is any relation. If you multiply z1 by 2, I will have the modulo will be 4 radical 5. And you can see that since I multiplied by 2, the modulo doubled. So it means that now this distance is double. So if it was here, it's going to be double approximately here. And what's going to be the angle? The angle is still the same. So if I'm multiplying the complex number by a positive scalar, just the modulo will multiply by the same scale that I multiply it by, but the angle is still the same. Now, if I multiply it by a negative number, what's going to happen to that one? It's going to be minus 8 minus 4i. If I also compare the modulo will be here, the modulo of this complex number, it will be also 4 radical 5. So it doubled. But what happened to the angle? What happened to the position of this one? If I don't want to find the angle, I just want, let's say this one was theta. So now I was in quadrant 1, now I'm quadrant 3. If I'm in quadrant 3, it means now I'm here. But this is the minus 2 z1, but also the distance is double. But what is the relation between the angle theta and the new angle that I got here? So it is the angle or the argument, it's pi plus theta. So it means when I multiply, so I can deduce the rule. If I have a complex number r cis theta, this is in the polar form. When you multiply by a positive scalar, what's gonna happen is that the modulo will be lambda r cis theta, the angle the same. But if I multiply by a negative number, what will gonna be the answer? The answer will be absolute value of lambda r cis pi plus delta. Now let's move to multiplying two complex numbers in polar form. So if I have that one 2 ei pi over 6 and that 2 is equal 4 ei pi over 3. You know when you are multiplying two numbers having the same base, what gonna happen to the exponent? We're gonna add the exponents. So, and here we'll have 2 times 4 is 8. So what's happening to the argument? To the modulo, sorry, I'm multiplying it. So what will be the new argument of that 3? It will be R1 times R2. And what's going to happen to the angles? I'm adding it. Why do we put plus 2k pi? Because it could be a whole turn, then I'm back to my position. So that's why we put plus 2k pi. So if I want to see what's happening when I'm multiplying two complex number, I can see that I have two transformations. The first transformation, it's the enlargement. It's I'm doing is يعني the modulo is bigger or it could be smaller. It could be as I'm doing zoom in or zoom out. And what's gonna happen to the angle? I'm moving, يعني I'm doing a rotation. So every time I'm multiplying two complex number, I can identify two transformation. But why do we multiply two complex number? What is the objective of multiplying two complex number? We will see it in this example. So what is the objective of multiplying two complex numbers? Let's do this example. If I have z1 is equal 4 cis 120 degrees and z2 is equal 3 plus 3. The first question here, I need to write the complex numbers alone in the Cartesian form. So to do it in the Cartesian form, so it's very simple. All you need to do is to write 4 cosine 120 plus I sine 120, and you know the cosine and the sine of those angles. So cosine 120 is minus half plus I radical 3. Then we develop, and I got this is the Cartesian form of Z1. The second question is to write the two in polar form. So to do it in the polar form, we need to find R first. Then to find the angle, don't forget we need to determine in which quadrant I'm working. Since X and Y are positive, so I'm in quadrant 1. So the angle is exactly the same. So what will be given by the calculator. So it's arctangent y over x, so it gives me 45 degrees. Why did I use degrees? Not I didn't write pi over 4, because since here it's already given in degrees. Normally we use pi over 4, pi over 6. We use radian angles, but when sometimes it's given in degree, we can use it. So now I have Z1 and Z2. I have it both in polar form and I have it both in Cartesian form. Now what is the second question? And here it's very important. I need to find that one and that two in the two forms. It means I need to have it in polar and I need to have it in the Cartesian form. So if I want to do it in the polar form, so it's very easy. That one times that two is equal. I have 4 EI 120 times, and the second one was 3 radical 2 EI 45. That's it. Yeah, that's it. And then I will multiply the argument. So it's 12 radical 2 e I, and then we add the angles 165 degrees. And if I want to find it in the this is the polar form. In the Cartesian form, I need to develop. So I have Z1 times Z2. I will develop the Cartesian form. So Z1 is already, I got it. I'm just checking my answer. It's minus 2 plus 2 radical 3i times, and I have 3 plus 3i. I just need to develop a normal develop minus 2 times 3 minus 6i, 6 radical 3i, and 6 radical 3i squared, so minus 6 radical 3. So, and I will write the finally directly my final answer. My final answer is minus 6, 1 plus radical 3 when I cut the real part alone, plus 6 times radical 3 minus 1i. So this is my real part, this is my imaginary part. Why I'm doing this? Now this is the important part. In part D, my question is deduce the exact value of cosine 165 degrees, sine 165, and they can ask you also tangent 165 degrees. So how I will be able to find the exact value of sine, cosine, and tangent just by comparing. Because when I say 12 radical 2 EI 165, so I can write 12 radical 2 cosine 165 degrees plus I sine 165 degrees. I'm going to compare the real equal to the real. So it's going to give me the cosine. Imaginary equal to imaginary going to give me the sine. And then I sine over cosine will give me the tangent. So let's do it. So all what we need to do is we need to compare, because in the polar form, Z1 times Z2 will be equal to 12 radical 2 cosine 165 plus 12 radical 2i sine 165. This is the polar form. If I want to write the algebraic form, or the Cartesian form, so it's equal to what? Minus 6, 1 plus radical 3 plus 6 radical 3 minus 1i, and then I just compare. So real equal real. It means I can write that I have 12 radical 2 cosine 165 is equal minus 6 factor of 1 plus radical 3. Then I will have cosine 165 is equal minus 6 1 plus radical 3 over 12 radical 2. Then you can continue your calculation by rationalizing, simplifying, and I will have the final answer for cosine 165 is equal minus radical 2 minus radical 6 over 4. I can do the same for sine, imaginary equal to imaginary. So I will have 12 radical 2 sine 165 is equal 6 radical 3 minus 1. And then I will continue the calculation and I will have sine 165. I will get the answer. It's equal radical 6 minus radical 2 over 4. And if I need to find the tangent, I can put sine over cosine, and I will have it equal radical 6 minus 2 over minus radical 2 minus radical 6, and you will get the final answer for tangent 165. This is the first part of this lesson. We'll continue the second part in another video. Thanks for watching. Don't forget to like, subscribe, and share my videos. Hope you got it.